In this problem, we're supposed to enumerate repeating subsequences of maximum length. So here is a repeating subsequence. 347 occurs here, and it occurs here. And it's of maximum length because they're no longer repeating subsequences. Over here, 3,3 and 3,3 repeat. It's okay that they overlap. In the original problem, I said that they shouldn't overlap, but then I gave you a wrong method to detect repetition, and that one didn't enforce that, so I changed the problem description to allow overlaps. Now it can happen that there's more than one sequence of maximum length. If you look over here, 2,3 repeats. In fact, it repeats 3 times. And 3,4 also repeats here and here. And so the way we're doing the reporting is that we report each occurrence. So here's the 2,3 that occurs 3 times, and then here's the 3,4 that occurs twice. And we just report them in the order in which they occurred. One could have eliminated repetitions in the report, but that would have been an extra task that I didn't want you to do. So let's remember how one finds subsequences. We've done that for strings, where we looked at substrings, and it's exactly the same thing for arrays. So let's say we want to find all subsequences of length 5. Then you start over here, grab the next 5, move over here, grab the next 5, and you keep on doing until the tail of the subsequence bumps against the tail of the whole sequence, and that's all your subsequences of length 5. Now we wanted to find the maximum length subsequence, so the clever thing to do is start from the top, which is also what we've done for strings. So this is a sequence of length 9. So there's no point in looking at the sequences, so the subsequence of length 9, that would be the sequence itself, and it can't repeat itself because you can't shift it. So you could look at sequences of length 8, then length 7, then length 6, then length 5, and so on. And as soon as you find one that is repeated, then we're done. So if we look at the problem description here, as it turns out, we have I shouldn't say we're done, but we have then found the maximum length. So if you look at, I've given you this is repeated method, and have a look at what it does. So it's given the start and the length of a subsequence. I should say that the start of a length uniquely describes a subsequence. So for example, if I have this start position and I have this length, then you know what the subsequence is. It is, in this case, 3, 4, 2, 3, 3. So the start and length define a subsequence, and here we now want to see whether it repeats. So what this thing does is it goes through all other subsequences of the same length. These are the starting indexes of all those possible subsequences. Notice the minus length back here because we don't want to bump past the end. We eliminate by this condition. We're making sure that we don't check that the sequence is the same as itself, because they all are. And then we call this same subsequence method here that gets 2 parameters. The I, that's the one that varies. The start, that's the one that was given to us. And then we check whether they're the same subsequence. That's the code that's down here. And that simply checks whether 2 sequences are identical. So we have one that starts at start 1, one that starts at start 2. They have the same length, so I only have to give the length 1. And then for each offset from the start, we check whether the value at start 1 plus I, that's the ith value of the first subsequence, and the value at start 2 plus I, that's the ith value of the second subsequence, whether they're identical. If they are identical, we're happy and we stay in the loop. If they're not identical, then we know that the subsequences can't have matched. If all of the length elements have matched, then we know that those subsequences are identical. So I've given you these two, and so the idea is that you should have had read through this code and understood what these methods do and then use them. All right, so now back to what we're actually supposed to do. So let's look at this example here. And so at some point we would have arrived at the fact that when we iterated downwards from 8, 7, 6, 5, 4, 3, we wouldn't have found anything. And then at 2, we would have found our first match. We would iterate through the subsequences. This one wouldn't have matched. This one here, the is repeating, would have returned true, so we need to collect it. And then the same thing with the 3, 4. The is repeating would return true, so we would collect it. The 4, 2 here wouldn't get us anywhere, but this 2, 3 would again match, because it matched before, and we'd collect it. This 3, 3 would get us nowhere. This 3, 4 we'd collect. And so on. So that would be, that was a 3 back here that I somehow got lost. So this 2, 3 would also get collected. So that's all easy enough when you do it on a sheet of paper. But how do we do the collection for real? Our challenge is that at the outset, we don't know how big this two-dimensional array is supposed to be. We don't know how many rows it has and how many columns it has. And that's a common problem. So there's one thing that you can do, and I've seen someone do that, is they first made an array that was definitely long enough to hold all possible answers, and then they would fill it in, and the filling in would just go this far. And then they would finally realize how big they really needed it, allocate a smaller one, and copy the numbers over. That's a viable strategy, but it's of course not as efficient as it might be. So what I've done instead is I've said, I know as soon as I get a positive outcome of is repeating, at that point I actually know what this dimension is supposed to be. That's the current length of my search. But what I don't yet know is, I don't yet know how many of them there are, and that could be any number of them. So I'll just collect those in an array list. Now it's possible to make an array list of sequences, but that's a little bit complicated. So what I said is I'll just have an array list of the starting indexes. So when I find this one here at index 1, then in my array list I'm going to collect the start 1. When I find this one here, the 3, 4, at index 2, I'm going to collect that 2. Then I'm going to find this 2, 3 here again at index 4, so I'm going to collect that. The 3, 4 would be at index 5, 6, 6. And then this 2, 3 here at the end would be at index 8, I believe. No. 9. And whatever it is. And so then I would collect these starts. And at the end, after I have run through all of the subsequences, then I will construct this array here, this 2D array, and return it. How do I construct it? Well, at this point I know how many rows it has, namely that's as many as I have starting indexes. I know how many columns it has to have. That is the length, in this case 2, of the subsequences. And then I need to populate it. So for example, to fill in this 2, 3, what do? I start at the 4, that's here. I take this subsequence and I copy it into here. So that's the intuition. Now to the code. So here, oops, this is still the old code. I enumerate all of the subsequences going backwards, exactly like we've done with the strings a while ago. So we start with the longest ones and go downwards to 1. Now, so these are these 2 loops. The first one loops through the lengths, the second one loops through the start of the subsequences. Then I asked, is this a repeated sequence? And if so, I add it to this starts array, the array list up here. Now at the end of this, one of two things will have happened. Either there was no repeated subsequence, in which case that array list would still be empty. And in that case, I just keep going through the loop, decrementing the length, and hoping for next time. On the other hand, if I have found one, then I'm now ready to do my copying. And the other thing that I should say right away is once I'm done here, I'm going to return right away. I'm returning in the middle of the loop, so I won't have to go further down. That way I get the ones of maximum length. In general, this returning out of the middle of a loop is quite powerful. It's an easy way of exiting the loop as soon as you're done, and you don't have to worry about all of the rest. All right, so here now I know how many rows I have, and I know how long each of the rows is. And the code that you find here does the copying. So for each row that I have found, I recover its starting index by getting it out of the starts array, and then over here I do the copying. Like I said before, when I'm done with that copying, I return immediately and I don't finish the loop to its bitter end. Now it's of course possible that I didn't find any repetitions at all. That means that this loop here dropped out when the length was 0, and in that case I do have to return something, and so here I'm returning this funny looking array with no rows and no columns. And that's it.